All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanaugh here. And folks, I'm very excited to have a very special guest today, someone who's been in this industry for a number of years at the forefront, doing very cool things in enterprise software, building cool technologies. And they're building something very interesting right now. I've got Dave Brewster on the line with me. He is co-founder of a company called August Data. They have an open source project called Eidolon. And guess what they're working on? AI agents. That's right. Artificial intelligence agents. They're cool. Like, could work some James Bond theme in 007, right? 007 secret agents, AI agents. They are little semi-autonomous entities that can reconcile, that can make decisions, that can determine what to do based upon changing environments. It's pretty cool stuff. So we're going to get into what that all means and what the folks at August Data are building. And with that, Dave Brewster, I'll bring you in. You're really trying to build a foundation for managing AI agents. Isn't that about right?
Yeah, that's exactly right, Eric. And thanks for having me. It's always a pleasure. So yeah, that's exactly right. So we're trying to build. We're calling it an agent server, because what we're trying to build is a foundation so that you can run agents in the enterprise in a secure and secure way that you can trust.
Mhm.
That is a lot different than a lot of the other offerings out there from that aspect. We have a lot of enterprise experience, and we're bringing that experience to autonomous agents. That's correct.
hmm and this is very interesting, like an AI server. So basically, it's like a control plane. It's a place where the AI agents are launched from and managed. Because when I started thinking about these, and I've been talking about them for a while, we were joking before the show. I used to call it interactive AI, and then this branding came along of AI agent, and everybody just piled on. And so that's what we're talking about now is AI agents, and they're very powerful, but how do you manage them? How do you track what they do? Is it a log file? How do you shut them down when they go rogue? Stuff like that. So could you talk to us about what the server has? Like, what are the capabilities that you're building into Eidolon, into this project for managing AI agents?
Yeah, absolutely. So, I think it all stems from the word trust, right? If you're running anything in the enterprise, you need to run it in a way that can be trusted. And that doesn't just mean security. So of course, what we build into the server is full RBAC on every agent that's running. We have the ability to push down any kind of current user, any kind of RBAC or anything like that to say a vector store so that we could query the metadata of a vector store and have the agent that's written only return data that the current user has privileges for. So of
Hmm.
course it's things like that. Being able to run in your secure environment, integrating with AD or Okta or whatever you have at the agent level, not at the server level, at the agent level, so that every agent can be secured. So security is one part of trust, right? Another part of trust is keeping track of every single request that's gone through, who made it, of course, when they made it, and how that spiders down through every sub agent that's there. And I think we'll get a little bit into the autonomy or the anatomy of an agent in a little bit, but every single call to an agent may call 5 other agents, may call 50 other agents, may just talk to a database. But you need to know through auditing mechanisms what that means and how you can trace those and who did what.
Right.
So when something does go wrong, you come back and you can see, you can do root cause analysis to see who made those. So that's a second part of trust. And for us, the third part of trust is monitoring input and output, not
Mm.
just from who did what, but also think of it as a manager or a QA agent sitting on the side, a security agent, if you will, monitoring all of the input that comes in at per agent, maybe, and all the output that comes out to make sure it's topical on the input and make sure that bad things aren't being returned to you on the way out. We all hear about jailbreaking LLMs every day. It's a lot harder when you have a very topical agent. So say I have an agent that's going to return records for sales from Salesforce, right? So records about sales that were made. It's much easier to monitor and manage that than it is something you can ask any generic question of.
That's
So, the
interesting.
three pillars of trust for us are security, auditing and governance, and then of course monitoring, trust and monitoring of the inputs and outputs coming in and out.
Yeah, this is very interesting stuff. And you talk about individual agents and some of the folks I've spoken to, including the CEO of Verint, which is a pretty big company. They do a lot of customer experience stuff. And they refer to them as robots or they're bots.
Mm.
And his argument is that you want one of these agents to be very specific in what it does. So, because I had asked him, I presume that these agents will get uh, more capabilities over time and be able to do multiple things. And their view is, no, we want them to do one thing very well, and then you orchestrate agents across workflows based upon what the task needs to do. Do you agree with that, that an agent should be very focused on what it does?
Yeah, absolutely. So, for sure, like if you're when you I think we've all used an LLM and experienced that over time, if you switch topics, it gets lost really easily. And I
Hmm.
like to equate this to humans, right? It's very easy in a conversation to get lost if somebody's changing context all the time on you.
Right.
So, and also from the human aspect as well. One of the things that people are getting into in the agent world is long-term memory. So having agents learn over time, in context learning is the word I like to use for it. And having an agent be very topical and do one thing at a time is the right way to go for all of those reasons. And empirically, we found that over and over and over and over and over again. Uh, so so when we think about designing an agent, and most of the agents on the market today that you can use that do complex tasks are made up of many subcomponents. So you may have a chatbot interface in the beginning, and that interface is good at just being a chatbot.
Hmm.
Um, but under the covers, that is maybe calling an agent for reasoning or planning. That may be calling an agent to do text to SQL. Well, the right way to do text to SQL is really interesting, right? You need something that can decompose the question into its root bits, given some in graph, usually information about your organization. The second part of that is you need something to look at the schema and decompose it. And then the third part is something that an agent that will go off and take all of that information and convert the text to SQL. And then, of course, maybe it's part of that agent or another agent to verify the results and rinse and repeat. So even something that seems like it's a tool to an LLM typically is made up of multiple calls to the LLM.
Hmm.
Now, I don't know, 4 months ago, maybe like people would call that multiple tools. The whole time we've been calling those agents. And I think now that vernacular is starting to catch on, where the definition of an agent isn't just these super agent concepts. It's the individual bits that make up an agent and the super agent itself.
Hmm.
I think as the nomenclature evolves, we'll maybe have different names for those things. But the word agent is confusing because of that today.
That's interesting. I'd like to go back in time often to kind of trace where we were and how we've gotten here. And I think back to the earliest days of applets. Remember, you would
Yeah,
create
yeah, yeah,
applets,
yeah, yeah, yeah,
which
yeah.
were like little teeny tiny applications, basically. And that's kind of what we're doing here with these agents, right? They're small, little semi-autonomous. Obviously, they're made up of code, but they can do X number of things. And I had mentioned to you before that it's kind of like a service within a service, right? So you've
Mhm.
got this outer component that's just waiting for inputs and saying, okay, so I'm going to give you something to do. Something calls along, calls upon it, says, hey, I need you to convert this text to SQL. It goes, okay, here we go. And then the function inside goes ahead and activates and does its thing, which is like it's almost like a coarse grained service from
Versus
the
a
old
fine.
SOA
Yeah,
days, right? You had fine
yeah.
grained services and coarse grained service. These are like very nifty little coarse grained services in a way, right?
Yeah, and that's how we equate it in our minds, because We're old guys. We're all old guys on this show today. So that's how we equate it in our minds is you know, as you watch computing, as I've watched computing evolve over the last whatever number of years, 30, 40 years, as you watch it evolve, we've learned a lot, and there's no reason to not take all of that information and use it in this new world. So yeah, that's exactly right. We try not to use the word microservice and service because I think it turns some people off. But
Right.
that's just us from a corporate point of view. But under the covers, what's really going on in Eidolon is every one of these agents are services,
Hmm.
and they have their own REST interface. And that our agents in our world talk to each other using that REST interface. Now, the interesting bit about that is if you look at an LLM and when things are called autonomously, they're called using JSON schema. And if you think of that tool as a service and you put a Swagger or Open API definition in front of it, then there's no difference. Like that line starts getting blurred. And in our world, that's what we've done. That's what we've implemented. So when you're implementing one of these agents, you're really implementing in Python a fast API interface that we make sure is docked properly and has is mounted at the right spot and all of that. But for us, it's no different. I can give you another really amazing example of what we do. If you have an open API definition for your REST API, we have an API agent, and all you have to do is point to the location of the open API documentation and maybe limit the number of calls that can be made so that you're scoping, as we talked about, you're scoping the agent down to be able to do a smaller amount of things, or not. If your API is well defined and rooted under a particular directory, you can just let it have at it, and that API is now autonomously available to
Hmm.
your system. So if you want to hook to ServiceNow and you've defined a bunch of endpoints in ServiceNow, right? Like you want to use a bunch of endpoints in ServiceNow, like you can just do it. It just works.
Hmm.
And it's super powerful. It's really, really cool and interesting to play with for sure.
That's interesting. So, I mean, in a way, you're breaking down how the operating system works. And, if you think about what Kubernetes did with containerization and being able to launch these little ephemeral processes, it's kind of like that, but I think there's an extra layer of complexity or functionality inside of these things. So it's like a container within a service layer, basically,
That's
that
right.
will launch, and it'll be just sitting there waiting for some call. And I'm guessing they all have an address, like that's their REST interface, basically is their address.
Yep, that's exactly right. And they're sitting there and waiting. And meanwhile, they're interconnected through registration
Okay.
with the LLM. And when an LLM decides that it wants to use that tool, again, it's autonomous, it calls into the API. And all we're doing is, like you mentioned, I think OS is a very appropriate way to think about it. So we're intercepting the networking calls, virtually, whatever, as in the OS, and rerouting them to the right place so that the service gets called with the right answer. And that service that gets called, as I mentioned, doesn't need to be an autonomous agent. It can just be an API point. It could be something you've implemented internally that's lived for the last 20 years. It's interesting you brought up Kubernetes, right? Our definitions of our agents are Kubernetes resources. They are the same thing. And
Interesting.
we just finished implementing our Kubernetes controllers. So in order to bring an agent up, you just kube apply your agent to the cluster with our controller installed, and magic happens. It's available. It's there. Now, of course, you have to configure it. You have to give a spec. There's a CRD for it, but it's there and it's available. And the more, you want more, you just keep kube applying, and there's more and more and more. So we take care of all the heavy lifting under the covers in the Eidolon project. And you have to worry about your business logic and how you want to bring them together. So we do think of it as Kubernetes. We think of it as a layer on top of Kubernetes that is this virtual autonomous layer that we've created, an operating system, if you will.
Yeah, what's really interesting about this, the way you just described it, I think is very compelling because what you've done is enabled this layer to integrate with an existing information architecture and use the resources that are there. So,
Yeah,
typically you do these rip and replace things, or well, I mean, there are plans to do rip and replace, and they usually
right.
don't go very well. But because you don't, it's just painful. I mean, it's painful to rip out an application that's been in place for a long time. Because A,
Yeah,
you don't really know every place it touches. B, you don't really know exactly how to pull the damn thing out. I mean, there are
right.
lots of factors that come into play here. And so to be able to overlay this orchestration capability onto an existing architecture, that's a huge deal. Like you just relieved so many operations people of headaches and nightmares and waking up at 2 a.m. like all that kind
Yeah,
of
that's
stuff, right?
exactly right. Yeah, yeah. One of the cool ways that we've used it is exactly that. Like we have a Kubernetes cluster that's running and it runs our software and it goes about its day. Well, we're software engineers. We're not DevOps engineers, right? And we've yet to hire DevOps. We're not live with our enterprise product yet, but we've yet to hire in DevOps yet. And so when something goes wrong with our Kubernetes cluster, we've just used that API tool to integrate into Kubernetes, the Kubernetes API, and we ask it to self-diagnose its own cluster.
Get out of
And
town.
it does. It says, oh, this service is this is trying to access this on this service. The log files say this, and it does. It just works. Now we haven't built a full product to do that. Like it's not foolproof, but it's pretty cool because it just kind of works if things stay in limits, right? This
I
would
see.
not work in a big corporate enterprise. I'm sure there are people out there building this for that, but you could build this as a DevOps person for sure and do that. It's just about the amount of data that the LLM can handle and how much you want to pay is really what it comes down to in tokens.
Oh,
So you would
interesting.
want to manage log files and things like that better. But what we build, it's kind of wide open, like whole hog, it'll just go and figure it out. So it's
Yeah, that's just crazy. I mean, it really
yeah,
is fun.
yeah,
But folks,
yeah.
don't touch that dial. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, talking to Dave Brewster from August Data. They have a project Eidolon, open source project, EIDOLON. Is that right?
Yeah,
Eidolon? EIDILON.
EIDOLON. Yes, you're
Right.
correct.
EIDILON, Eidolon. I looked it up. It's an interesting concept that you played
Yeah,
into there. But I want to talk about machine to machine conversations because I tell you, so I started using ChatGPT or whatever it was a year and some change ago, and I'm talking within like 10 minutes of playing around. I was like, wait a second. If it can write in English and French and German, I bet it can write in COBOL and JavaScript and
that's right.
HTML.
Yeah.
Yeah, it sure can. And then the next big epiphany I had, and I'm very curious to hear your thoughts on this, is like, machine to machine communications can seem very cryptic and Byzantine to a human being, but when you get down to it, it's not that complex. It's
Right.
not as complex as a human language where you've got tens of thousands of words that have all sorts of different meanings. Typically, machine to machine language is some pretty clear cut data that's going back and forth. So I'm like, well, wait a second. Does that mean that an LLM could ascertain what the machines are saying to each other? In other words, could this be an entree to use this technology to troubleshoot complex systems? And I think that the answer is yes, but what do you think?
Yeah, and for sure it is. Absolutely. I mean, we use it for that every day. I'm
That's
I'm in the middle
crazy.
of creating a Helm chart for said Kubernetes operator. And like, I mean, I don't know how to create a Helm chart. I do now, but I didn't learn like so that's the easy part. But for it's the API to API communication. We actually have a great story in here where we have somebody using it that works for a company where they have to deal with lots of different state regulations and call APIs for different state regulations.
Right.
And they have an API in their system, right?
Right.
That they want to call, but they want to get that translated so that when they need to talk to the regulatory API to file a paper or do whatever, they don't want to have to translate that to all the states. So they've created an autonomous gateway where they just have an agent per state that's read the open API, that's an expert in the open API for that. And the agents all talk to each other, knows what state to go to, knows what agent to go to because of the state. And talk about a smart API gateway. Yeah, you can diagnose, but you can even take it a level above that and just not write the code, like not even write the code. Just
Wow.
have to be done autonomously, all through driven through some sort of spec that
Right.
describes the API. Now he got lucky. There are open API specs for this, but I imagine it would work if there was good documentation as well. I mean, English
That's
versus
that's
JSON schema. Yeah,
that's so interesting. I mean,
yeah,
because these are very, let's face it, regulations can be very complex for humans to understand. Like you sit there and you read this thing and like, hold on a second, what do I have to do? And I
right.
can tell as a copywriter, they're hard to write. They're
Yeah,
hard to conceive, they're difficult to write, and they're hard to receive and understand and ascertain. It's not easy to do. But these large language models, I think, because of their pattern recognition capabilities and because, well, the reasoning I think is still in motion. I think there's going to be a lot of activity on the
yeah,
reasoning
there is
front,
for sure. Planning,
because
scheduling, reasoning. Yeah,
right, exactly, which is it's basically sorting through a whole bunch of different options and being able to determine what is the proper set of steps, right? You think about how an engine beat the best chess player. Well, that's actually fairly simple because you're just running through every possible move, every possible
yeah,
time, and figuring out the ways to do that. But that's kind of a reasoning thing, right?
yeah. Reasoning's the good thing about reasoning is research into reasoning, planning, and scheduling has been going on since I graduated college in the 80s,
Wow.
right? Like
Right.
it's been going on a long, long, long time. I mean, I took classes in AI at Ohio State, and I took that class, and that's been going on a while. LLM reasoning is a different beast. But folks will, and probably already have, figured out how to merge those two to the point where maybe you'll have an LLM that is specialized in reasoning. Maybe it will be a built-in part of the LLMs that are there. I don't know, but that will be a solved problem in a year or two. And
Yeah.
not solved, but will be solved to the point before to beat the 80-20 rule, which is kind of the way I look at it. But
Interesting.
I mean, if you take my example of the APIs farther, why create APIs anymore?
Right.
If you have a system that people need to talk to, why don't you front that with an LLM that's properly secured, using something like what we're building, and then let people talk to it to get their information out instead of an API that has a UI that has blah 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 blah. And then if you want to have another agent talk to it, it can talk over English. It's quite
Mhm.
capable. So why limit it? Why spend all that effort taking something that is data that's in human language, transforming it into machine, into
Right.
JSON, whatever,
Right.
so that you can transform it back out into a UI that humans can understand. The whole process in engineering, what we've done, especially at the data layer, right? Like, I don't know if folks know, but my background is in data. Like I've started data companies. I've been part of early application server companies. I've been part of data for the last in enterprise for the last 30 years. Um, the the thing we do in data is jump through a lot of hoops in order to make things make it so that systems can understand what's going on, so that then humans can ask questions, so the systems can answer the problem, answer
Right.
it. Well,
Right.
that all gets circumvented now. Like
Right.
we just need to think differently in order to produce the right results. This is a game changer. This is and I think agents are a vehicle to bring upon that change. But what we're building today is not going to be the answer in 15 years.
That's
Guaranteed.
interesting.
There'll be three or four more revolutions. Maybe not at the LLM level so much. I think there's more there, but at the usage of them, because we're still used to programming
Right.
uh, in code and not guiding.
Well, so I go to these conferences fairly often, and I was at the Boomi World Conference a few months ago,
Mm.
and their chief product and technology officer made this one comment that I think really resonated with me, where he said, because he was thinking about AI agents and how they work and what they do and what impact this will have on the software companies' processes, building new tools, building new platforms. And he said, I thought to myself, do we even need connectors anymore? And so I
Right.
called our head of engineering and said, do we need connectors still? And he goes, yeah, we still want the connectors. And really for more of a control plane perspective is it was
Sure.
his
Yeah.
argument. And I'm like, but to me, that was very telling because it's like, this is a connector company saying,
Right.
wait a second, do we even need these things? And kind of to your point, depending upon how you go about it, if you have the security and the governance, and you talked about the CRDs, basically, if you have your definitions right, then yes, these things do all the other stuff you wanted, and they do it in a much leaner fashion. I think that's the key, right? With the monolithic applications, like you think in SAP ERP
Right. Right.
instance, like the old, even before HANA, right? Like the old ECC or whatever, just the mountain of code that went into doing
Yeah.
everything,
Yeah,
and
yeah.
then trying to figure out from the outside, like how that all works and
And
how
it
to
was all in
connect
German.
to
All
it.
the schema was in
Right,
German.
of
So
course.
yeah.
That's right. That was the other thing. It's like, what does this
Yeah.
mean?
Yeah. I remember
Guten
those.
Tag.
Yeah. Yeah. I remember those days. So yeah, I mean, you imagine how much easier it would be to program that system with an LLM now?
Right.
Just even the German English part, like, but
Right.
for everything else, like, and people do that today. Everybody does that today. I'm sure. I mean, I'm not so much in the data world right now, but I'm sure if I went and talked to somebody working in using DBT and in the enterprise world, and they want to understand the scheme of a database, they don't try to figure that out themselves anymore.
Right.
They drop it into an LLM and start asking questions like,
Right. Isn't that crazy?
why would you, yeah, why would you do more than that? And and with the explosion of LLM capabilities over the last month or so, or sorry, the last 6 months or so, we're now with the new Claude that's out, the 3.5 Claude. Wow. I mean, not only do you get the answers, you don't get an attitude. So
Yeah, I
yeah.
love I'm a big fan of Elon Musk, but his idea of having a an LLM that's a smart aleck, I'm like, yeah,
It's a
I'm
little
not
too
sure.
much, but Claude's really nice because it's not so sure. It's not narcissistic like all that. Anyways, we're getting a little bit off topic, but
That's funny.
yeah. So yeah, it's
Well, and so in terms of capabilities, in terms of what you're building in this open source project, and again, it's Eidolon, EIDILON, I think Eidolon.
yeah,
Uh,
EID. Look, I'm going to spell it out. It's going to be easy. Yeah, EIDOLON.
LON. Okay, I got it wrong.
Eidolon. Yeah,
Eidolon, an
and if you
idealized
yep.
person or thing, right?
Right, right,
It's an
right.
idealized vision of the future, right?
Yeah, if you look at Eidolon and what we built and what's there, we're trying to build a framework. We have built a framework that allows people to focus on business logic, really, just really short and simple, um, without going into too much crazy detail about the framework that's there. We pull the LLM and everything complicated away from the user
Hmm,
so that they can focus on their business logic. But yet, if you want to override a component, you're not doing what you're doing in LangChain and going and finding source code and rewriting 6 different bits just to get to the prompt, right?
right.
You want to override a prompt, it's a spec override in this Kubernetes spec I was talking about, in one little tiny configuration spot, and you're done. So it also allows different engineering groups to focus on different things. With one of our advisors, we were having this discussion the other day of, imagine if I'm an SAP and I want to write an adapter that queries SAP or ERP and uses an LM to do text to SQL for that. So do you think that would work in Python well? Do you think they have a good adapter in Python for that? Probably not. It's SAP, probably not, maybe. I don't know. But even from there, like the developers that you would find that would know that stuff don't know Python. They're not, that's not their natural language. That's not what they do. So with Eidolon, we allow you to write the code that is for your services that you need to be decoupled, and then very easily couple and bring that into the system. We're focused on modularity, and I think that's a computer science principle that hasn't been as thought about as it needs to be in recent years. So again, if you want to bring out a different component and swap out a different component, it's very easy to do. If you want to have 4 different LLMs that you're talking to in one agent, you can very easily do that. We don't recommend it, but if that's your software pattern that you need to have, where you're bouncing between them very rapidly, maybe with low latency or something like that, and they're small local models or something like that, very easily you can do that. If you want to call an agent from anywhere else in your system, again, it's a REST API with an open API 3.1 spec attached to it. So that's immediately available for you to do. And it's all open source. Every single bit of it's open source.
That's cool. Yeah, because when I think about what's happening with these LLMs, foundational models in general, of course, there's a lot of other AI out there, traditional AI, if we could say that, which works very well in certain circumstances for certain use cases. You do have to be careful about when you use an LLM versus
Right.
when you use a regression model or just some other way of doing things, because it's horses for courses, as my old co-host used to say years ago. You got to understand what you're trying to do. Like giving an LLM a very complex math problem is not a proper use of the
It's a
technology.
horrible
That's
thing
not
to
what
do. Yeah. Never do it.
it's
Yeah.
just not what it's designed to do. It's designed to reflect back text according to a prompt and its training. And they're really consensus engines more than anything, because they've trained on all this information, and so they're going to give you an average of what they've seen based upon your prompts and their vectorization, basically. But
Yeah.
nonetheless, it is very compelling what they can do. And when I look at this, and our next break is coming up here, but I view it as the next major change in how we build software and how we leverage software. And I think that really every major enterprise software company is going to have to figure out, where do they fit in the RAG model? Where do they fit in terms of how they interact with LLMs? Because that whole interface is going to be huge for lots of reasons. One of which, just to talk about decision support, because I know you were in the data prep years, co-founder of
Yeah.
Paxata, now got bought by Data Robot. So you understand how all this stuff works. And guess what? It's a really, really seriously big deal to manage all that data. And the old way of doing that is very monolithic, and it's overkill,
Right.
basically. And what's interesting about these agents is they can go and tackle a particular task very quickly and very efficiently with very little resource, as opposed to the bulldozer way that we used to do everything. So it's going to save time, money, all kind of stuff. But folks, don't touch that dial. We'll be right back with Dave Brewster of August Data. You're listening to DM Radio. All right, folks, back here on DM Radio. Fascinating conversation with Dave Brewster, co-founder of August Data. They're working on the Eidolon project. I'll get it right this time. Eidolon, Eidolon. Look it up. It's an ideal person or concept. And this is an ideal worldview. It's an SDK, a software development kit for developers who want to work with Gen AI. And we're just sitting there talking about things like decision support. And you had a great quote in our little break there when we were chatting about how IT management should be all about getting information to the information workers. IT is about keeping the systems running historically, right? It's about standing up the systems and then keeping them running is what you want to do. And then everyone else uses the systems, it gets information from there. But the IT people need information about what's working, what's not working. And you've said already that you use these LLMs to self-diagnose, which is just like, wow. I mean, that's
Yeah.
so cool. Could you talk about how that works and the implications of it?
Yeah, sure. I mean, again, it's just getting information to the information worker. So if you're an IT guy and you're trying to figure out why something isn't working, 80% of your job is you get a pager call, guy or gal in the middle of the night, you get a pager call, and you need to wake up and you need to figure out what's going on.
Right.
Well, imagine showing up and the LLM has diagnosed the problem and given you a potential solution, and you were there and you say yes or no, or better, like it was a very simple problem that somebody misconfigured a port on a random service, or a service crash needs to be restarted, whatever, right? And the excuse me, and the LLM took care of that for you because it's a very obvious choice. That's
Right.
great. So now we've gone into the realm. Let's stick on information to the information worker, because we've gone into the realm of of self-healing and things like that. But getting information to that information worker is just like that. Another classic example, I worked with this guy at two or three companies, and he's a support guy, and he was the top level support guy. His name is Ashok, and we always used to say everybody needs an Ashok in a box because this guy is amazing. He would I Guidewire Software, which is where I was a few moons ago. He very complex insurance software system, very complex. And a customer would be having a problem. I ran the platform team, and he would come to me and say, there's a problem that they're having. I've diagnosed it to this. These are all the processes that we're running. This is the log files, blah, 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 blah. And this is the problem in the log file. So first of all, not very many support people can even do that. And I would say, I don't think it's the right problem. As an engineer, you would always argue with him. Sorry, Ashok. Anyways, he would come back with the source code and say, this is what I think this is where the bug is in the source code. This is the problem. It matches what's going on. And he would be right 90% of the time.
That's crazy.
Well, imagine having an LLM do that. It's not that difficult. It's not that difficult to have an Ashok in a box. So yeah, right. And shout out to Ashok if he's listening. But yeah, so it's not, so LLMs are capable of doing those things very, 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 very well. And in an agentic system, you can imagine how you would split that problem up. You would have an agent per system, maybe an agent for the log files, maybe an agent for the monitoring system. They would all communicate with each other to see what anomalies are there, what time they happen, on and on and on and on and on. It's not that difficult of a problem to solve. But without a backplane with something like Eidolon to manage all that for you, doing that with LangChain today is one giant Python program. Maybe you could use LangGraph to do it in a couple, but you need the enterprise level management of all of that's going on, so that when something does go bad, you know what happened. So, anyways.
Yeah, and this gets back to, that's a good segue to help people understand what you're working on here. It gets back to that control plane and capturing the inputs and the outputs for every one of these things. So let's say you've got 20 agents out there that are orchestrating and doing different things. And to my mind, this is what enables the agility, is that you have these small agents that can call on each other to do things because they know agent D is very good at SQL to text or text to SQL.
Right.
Agent A is good at retrieving documents, for example. So, and do you also have sort of a master agent that kind of works through what needs to be done and kind of tells them to do things, kind of like the transformers with
Yeah,
the
I mean, yeah,
LLMs?
we do have we are working in the process of working on better scheduling. We have manually scheduling, right? Anyone can write code and hook things together manually. But what we're working on right now is autonomous scheduling and autonomous reasoning engines to help you do that. It's a hard problem, as I said, but
Right.
I think LLMs are making that easier. But yeah, you do hook them together, and you would be surprised, like just with very easy system prompts, you can just by describing your other agents in a very verbose way, the LLM will get it right most of the time today.
Wow.
But we do want better planning. We do want control of that planning instead of it to just be luck of the draw, luck of the next word, I guess is maybe the right way of saying it with an
How
LLM.
interesting. How interesting. Yeah, and I get back to the fact that you overlay, and I think this is the key, right? Because rip and replace is always dangerous.
Right.
But when you overlay, and I'm guessing over time, when someone installs this and starts using it, over time, you'll be able to figure out which systems you might be able to sunset, right? I
That's
think
right.
that's the other side of the equation here, is that, historically it's been kind of a gut instinct feel like, okay, I think we can pull the plug on this thing. There are stories of Elon Musk when he bought Twitter's walking around pulling out cords
Yeah.
from servers just to see what breaks, which is it's something you can do to learn how stuff works.
Yeah.
But obviously, at the enterprise, you don't want to be
You would
doing
do that.
that.
No, no.
You get in a lot of trouble. But at least you can learn. And I think this is this is like a stepping stone into the next era that will be largely run by AI agents. What do you think?
I think so. And I think we're in a transition period. I do. We talk about it every day because, you know, enterprises aren't picking this stuff up and running with it like they have other technologies because they don't trust it yet, right?
Right.
It's a
Right.
trust thing. And it's a trust at the legal side, but more importantly, it's a trust at the worker side. And if you have some empathy for the knowledge workers at a company, they're probably pretty afraid right now of some things going on, right? If I'm a chief data officer and my job is to acquire data technologies and figure out how to put them together and run them, or I'm a CIO and I'm literally in
Right.
charge of running it,
Wow.
um, that's going to change, and changes makes people fearful, right? So there's a lot of distrust, but you know what? There was a lot of distrust in when the internet entered enterprises. You know, I'm old
Right.
enough to have been there when application servers were created and people were exchanging goods over the internet for the very first time. There was a huge amount of distrust.
Right.
Um, I understand it. It's the distrust probably should be there until good technologies are available, but it will change. Eric, you and I both know, in order for companies to survive, they will have to change and
Right.
they have to embrace this.
Yeah.
Yeah,
Yeah, that's right. I mean, you need some kind of a skunk works project, at least in your organization. You have
that's right.
to spend some time digging into this. And we got a podcast bonus segment coming up here, which is only about 8 minutes, but to get his to get Dave's brain brewing here, I'm going to throw out what I'm going to ask him in the next segment, which is how do you actually go about training your or fine tuning your model or just populating your vector database, which is really what most people are doing, part of a RAG architecture, retrieval augmented generation. Like we'll walk through what you actually do in order to populate your vector database. And I heard from a guy named Brian Raymond of Unstructured IO this great concept. He calls it anchors of truth. So I love that term. It's really, really
Oh yeah.
interesting.
Okay, that's great. Yeah, yeah.
Anchors of truth, that's your embeddings. But we want to talk about how you go about doing that. Are you basically running a series from your CRM, for example, or from your Salesforce or from your ticketing system? Because what you're trying to do is populate vectors in your vector database, which becomes the repository of facts. It's like the fact set basically that you want your particular applications to refer to as you're trying to solve through these problems. I don't know exactly how that works. I'm guessing that you kind of feed it in, you're loading it, and then over time it just gets more and more robust in terms of how much information it has in there. I think that's kind of how the process works. But we'll ask Dave Brewster about that after this final break. We are talking to Dave Brewster of August Data and the Eidolon Project, EIDOLON. Look them up online. We'll be right back with the podcast bonus segment. All right, folks, time for the podcast bonus segment here on DM Radio. Talking to Dave Brewster of August Data, and he is running the Eidolon open source project. It's an SDK for developers to use when building trusted Gen AI applications. And I just wanted to touch in this last segment here on how you populate your vector database, which of course is part of a RAG model where let's say you want to connect to an LLM, do your prompt, you hit enter. First, it goes to your vector database to gather the fact set. Then it goes to the LLM to spin up the text, and then it comes back, and you could possibly have a double checking agent to look and say, okay, does this look good? Yes or no, to kind of give you a final word on that. But can you walk us through what it actually looks like? Like, how do you actually populate a vector database? How do you do that?
Yeah, for sure. So first of all, at August Data and specifically in the Eidolon project, what we say is RAG isn't a use case. RAG's a technology, right? It's not a
That's
use
funny.
case.
That's
It's the
funny.
use case is, I have customer service docs I want to go search or something like that. It's a Lego block. It's a building block. It's
Right.
no different than an app server way back in the day, like even today with the fast like a Python application server, no different than anything else. But it needs to evolve and it needs to be built. So what is RAG? So for unstructured data, and I'm going to underline the word unstructured, what we found is, or not us, but what the world has found is that when you want to search unstructured data, you can break the problem down into what's called vector embeddings, which is the same way LLM works, right? Under the covers, it's the same way an LLM works. So if you take a series of tokens and you take a document and you tokenize it, and this is exactly what happens when you're just chatting with an LLM. You take the text, you tokenize it, and you then embed that tokenization, those tokens with, and turn them into a vector using everything inside of the LLM, the same way it does it. Turns out you can store that in that vector in a way that you can do a similarity search against it with another query that will return the data that most closely matches that. So if you think about how an LLM works, an LLM is just guess the next word. I mean, very, very powerful version of guess the next word, but it's just guess the next word. And so with vector embeddings, you're kind of getting the same thing, but it's not that easy. It's not that easy at all. There are two parts to RAG. There's loading the data, it's called an embedding process, but loading the data into a vector store. What is a vector store? Well, we talked about these vector embeddings. A vector database simply allows you to take a vector coming in and compare it to other vectors in the database very rapidly using math, just statistical math. And so you load the data, you turn it into a vector database. There's a whole big process to do that, right? And then when you want to go query it, you need to then the RAG, part of RAG actually talks about the retrieval augmented generation. So it's all about the retrieval and how you retrieve that data from the data store. So let's just talk about the retrieval part. In the retrieval part, people usually talk about it as splitting the problem up and parallelizing it in some way so that you can query for similar things in a database so that you find what you're looking for. So let's keep it simple to start with. I have a question. The question comes in, it gets embedded. I then go to my vector data store. I find everything related to that that's in there. I take everything related to that. I put it in my prompt with the original question. I send it all to the LLM, and it answers the question given the embedding, the context of what's in and the documents, the data that's there in the same context, and gives you an answer relative to the context you gave it. So it's like, to simplify it more, it's like going and finding the snippets of the document or the image or the speech and pasting them into the ChatGPT window that you're interested in, and then asking it a question with all that data already there. It's exactly the same as that.
Yeah.
Now it gets way more complicated because of context window limitations. You can't take, 1,000 million line documents and shove them into an LLM. Like that doesn't work. So on the way in, you typically break your documents into chunks.
Right, chunking as they
and
call
there's
it.
all kinds of techniques to do that. There's some great companies out there that do it that do it very well, and that's all they focus on. You mentioned unstructured. Datavolo is another one. Amr Awadallah, what's his company? Anyways, there's another company that Amr has. He's going to be very mad at me for not remembering the company.
From Cloudera days, right?
So
Isn't that the Cloudera guy from
that's
way
the
back
Cloudera
when?
guys. Yeah.
Ah,
Anyways, he's going to be so mad. Anyways, it's all good. And that's what they focus on, and they do a very good job. The Datavolo guys are NiFi, Apache NiFi, unstructured.
okay, sure.
And as you
Right.
mentioned, the other guys are the Cloudera guys. So they understand that world very well. So that's all about getting the data in. But what we do really well is the retrieval of that data, right?
Interesting.
And we have different techniques to pull that off. I'm not going to go too deep into it, but it's about rewriting the query and understanding that. It's about, as you said, agents, monitoring and understanding kind of what comes back given the question, and either rewriting the question or asking it again, in some different way. as a circular agent. There's a lot of new techniques around agentic RAG that are coming out. There's hierarchical techniques, et cetera, et
Wow.
cetera, et cetera. The great thing about a platform like us, we have one interface. You code against that interface. And as new techniques come out, you change the module you're using, and voila, you get better results.
Wow.
You can tune the parameters by tuning parameters, not changing code, et cetera, et cetera. You can do it at runtime in your Kubernetes cluster,
That's
et cetera,
crazy.
et cetera. So yeah, so that's RAG in a very brief nutshell. It was very
Yeah.
difficult to not go too deep into that. It's
It
complicated.
is it is complicated, but, it does mimic how humans think, and that was the whole idea of deep learning originally, right? Is to
Yeah.
really mimic how the human brain, as so far as we know, how the human brain works, and we're getting pretty close to getting a good understanding of all that. But folks, look these gentlemen up online. Dave Brewster, he is with a company called August Data, just like the month. August Data means strong, strong data. And for Gen AI trust, it's all about trust. And look up Eidolon, Eidolon, the open source project. We'll talk to you next time. You've been listening to DM Radio.